Today we are going to discuss what are the different kind of application we can build using Java, how Java was invented, what are the different versions of Java we have. So these all kind of stuff, and then the JVM, like how internally it works. All right. So I'm going to share my screen with you guys. I think you can see my screen now. Yes or no? Can you see, guys?
Yes.
All right. Yes, yes, yes. Okay. So let's start with history of Java. I'll share one document with you guys after this session. Like the theory part will be there, whatever we are discussing. Okay. So Java was invented in 1991 by Sun Microsystem. The core member of the team were James Gosling, Patrick, Mike, and one more guy was there. I'm not recall the name. I'll share in the document. All right. So there were four members in the team. So at that time, there was like languages C, C++ was the language at that time in earlier 90s, which were already there in market. But there were some limitations, like graphics were not that good, right? They were not robust like Java. So these four-member team came with an idea or with a project. That project name was Green Project. Initially, the project name was Green Project. So they worked on a language that is later on called Java. So what they did basically, when they were working on developing Java language, they were consuming lots of coffees at that time. So they have decided like we are doing that kind of task just because of the coffee we are consuming. And the time the coffee they were consuming was imported from one island called Java. So based on that island name, they named it as Java. So initially it was a green project. Then later on it was known by OEC, and because of this Java island, sorry, one second guys. They named it Java. So that was the quite history how the language was started, who were the core member. So if you see in documentation, you will find the name of James Gosling, who is known as father of Java. So initially, the initial version was launched by Sun Microsystem in 1995, but they have started working in 1991 on this project. The project in the beginning days, initial days was called Green Project. Later, then they called it Org and then Java. So James Gosling was the core team member who was leading the team with Patrick and Mike. So initial version of Java that is called Java 1 was released by Sun Microsystem because at that time James Gosling were a part of Sun Microsystem that is now acquired by Oracle. I believe most of you guys already know that. Okay, so this is quite history, like how it was started. Then initially for commercial use, it was launched in market in 1995. And when we say application of Java, so there are different kind of applications we can build with Java language. For example, web application, mobile application, standalone application, and one more is there, which is standalone application, web application, enterprise application. So these four kind of applications. Also, these time we can see the use of Java in devices like washing machines, ATMs, setup boxes. So these kind of project we can build with Java language. I have listed 4 points: enterprise, standalone, then web application, and mobile. So enterprise, web application, and mobiles are quite popular in the market nowadays. So I believe every one of you knows like what is an standalone application, what is a web application, and what is mobile application. So I am not going in deep in these details. All right. Now let's discuss about the versions of Java we have. So for now, from the initial days of Java, that is 1995, we have number of version released by um, in earlier days released by Sun Microsystem. Nowadays, releasing by Oracle. So there are different version of Java like JDK 1, JDK 2, then JDK 3, 4, 5, something like that. And then the latest version Java has released is Java 15. So and if we talk about the industry, most of the industry is working on Java 8 or 9 or 11. So in total, like 80% of people from the market are using Java 8, and rest of the people are using Java 9 and 11. And some of guys are also using Java 13. Right, let me open that document that I was going to share with you. I believe you can see this, right? We have already covered Java features. Yeah. Now next thing is like what is JDK, what is JRE and JVM. So JDK stands for basically Java Development Kit. It provides environment to develop and run Java applications. So for example, we were talking about the byte code in earlier class. So what exactly a byte code is? A byte code is a intermediate code which is converted by JVM into a machine readable format. So basically, when we have JDK, it comes with tool like Java C. Okay, let me show you like different tools we have with Java. Okay, keep an eye on my screen. And in case you guys have any question, please feel free to ask. All right. So I have two versions installed in my system for Java. Let me open this JDK um, 8. So now you can see I'm on directory JDK 8. Here is a folder we have that is called bin. Okay, in this folder we have Java C, which is basically our Java compiler. Java doc, basically used for Java documentation. Uh, One more is there that is called RMIC, basically used for remote method call, right? So these are the tool, like key tool are the key tool is there to generate certificates and digital signatures. Okay, so these kind of tool comes with JDK. When we install JDK, these all tool comes to help us in our development. Yeah, we run a command Java that is run by this tool. You can see guys the Java tool, right? And then what we have another part is that is called JRE. Now JRE, in JRE we have a folder called lib. Here you can see we have a different kind of jar, Java WS JCE JFR. So most important jar here is rt.jar. Okay, what basically a jar is? A jar stands for Java archive. A Java archive file basically contains packages, and in simple words, a package we can say it's a folder containing multiple classes and interfaces. Okay, so this is called JRE. Basically, it is required to run a program. JDK we need for development, JRE we need for execution. So if someone asks, like, if we don't have JDK installed our system, but we have JRE on our system, can we run a Java program? Yes, we can. Okay. Now, JRE, Java Runtime Virtual Environment, provides environment to run Java applications. Like if you have a class file ready with you, then you don't really need um, the Java code or this JDK. Okay, because if we see JRE, you will find we have Java tool here. You can see, right? But if we say Java C, I'm not sure it will be there. And one more thing, guys. Uh, yes, in yesterday's class or day before yesterday, we were trying to set the path that we were able to do, but when we were trying to delete, it was not reflecting. But once the class was over and I was trying to run that command, that I was getting uh, Java C or Java is not recognized as an internal or external command. Have you faced the same issue when you tried that? Please confirm, guys. Yes. All right, Harsa. Okay. Okay, let's move back to the document. Now, third thing is JVM, Java Virtual Machine. What is a Java Virtual Machine? It is an interpreter which is responsible to run Java applications line by line. Now, the key points are JVM is a part of JRE, whereas JRE is the part of JDK. You can see, guys, when I say JDK, so in JDK we have a JRE folder, right? You can see it here. That's why we are saying JRE is a part of JDK. And when we say JVM is a part of JRE, what basically it means? This Java tools we have here in this folder inside JRE, you can see the path, like I'm in JDK, then JRE, then bin, and inside bin we have Java file, right? Which is basically responsible to create a JVM at runtime. Like when we say Java and some class name like test, what it does basically, this command, it initiates a JVM, and until the program is in execution, the JVM is running. Okay, I'm just coming to that JVM point in detail, but I believe you got the brief idea. If yes, then please confirm. I believe you got it. So I'm moving further. Okay. Now let me show you one more thing that we have done. Okay. We have a class file which is hello world.class. Okay. For this, we don't really have the Java file. I have intentionally deleted that file, and let me just run this Java, and what is the name of this class? Hello world. Sorry, we do not really need to write class. Okay, so you can see for this we have just wrote hello world to be printed on console. Now if I open this class, what we will get is the byte code. Basically, some of the words you can understand, and some of the words you will not be able to understand. Like from this we can read this hello world, line number table, hello world. And if I try to modify something like let me make it hello Java. So what I am doing is I am tempering the byte code. Okay, I want to insert like my code instead of the world. I'm writing here Java, and I'm trying to run it. So what we will get is a Jni error has occurred. Please check your installation and try again. Means our file has been corrupted. Are you getting my point, guys? Okay. So when we say Java and hello world, so what is basically going to happen is a JVM is going to initiate, and inside that JVM, the program will be executed. How it will be executed, we will see in next step. Any doubt so far, anybody? Okay, one more interesting thing that you should know is that, like, when I say Java and I say hello world.class, let me just control Z it once. Desktop cd new folder 3 Java. So we are running this command to run our program, but behind the scene, what exactly is happening? Let me just show you that. Okay, so I'm running this command using the verbose command. So keep an eye like what is gonna happen. Let's look from this beginning. Yeah, when I run a command Java verbose hello world, so what kind of process run by our this command? So you can see open C program files Java JRE. librt.jar. What is that actually? uh, Here you can see, let me go to that path, program files jre librt, java jre 1.8. Okay, here we have jre, then we have lib, and here we have the rt.jar file that I was talking about. So what exactly in this file is, there are multiple classes and interfaces written by Java so that we can just go and use. Like for example, we ran a program of hello world. Let me just open the code as well. Wait for a moment, it's getting open. Yeah, so this was the program we wrote in our first or second class. So here you can see, like, we have a inbuilt class we are using in our program, that is called string. Another class we have is system. Okay, so when we say run our program, so what basically Java does, it loads all the classes which are required to run a program. Like string is required, system is required. So you can see here, first of all, it loaded object class. So basically, object class is a class which is called parent of all the classes in Java. Like we will learn a concept of inheritance in coming days, where we can reuse our classes using that inheritance feature, right? Like in general we can just say, like we have our parents, we can use their properties, their uh, features, right? So in similar way we can program our applications to use existing classes instead of writing our own code. We can reuse the already written code. Okay, so first of all, it loaded object class, then serializable, then comparable, char sequence, and in meanwhile, let me look over the class that we are looking for. It was system. Let me try to find a string. Yeah, string. Yeah, here we go. So you can see loaded java.lang.string from C program files Java JRE 1.8, and then this, right? In similar way, there might be a class that is called system. Let me look over that as well. System. Yeah, loaded java.lang.system from this jar file rt.jar. Okay, and now let me go down. Here you can see our class name loaded hello world from file, and the file is basically exist on path c users hp desktop new folder 3, right? It has loaded our class, right? And then some other classes, and finally we are getting this output. So you can see how much of work the JVM basically is doing, right? So what exactly loaded means, it is loading the classes from that jar file into JVM, right? Now you are wondering, like, why these many classes are getting loaded, because we are using only two. So this will be, I'll discuss this later when we will read inheritance or association, right? If I go with this topic today, so it might make your learning complex, so I'll not discuss it today. Okay, Any doubt so far? Your voice is cutting down in between. I'm not sure. I am the only one facing this issue. Guys, please confirm if all you guys facing the same issue or only Gurpreet is facing this issue. Please confirm, guys.
I'm good.
I'm good too.
Okay. Okay. Anyone else who is facing the voice issue from my
I'm
end?
good. I'm good. Able to hear
All right.
clearly.
All right.
I'm good. Yeah.
Okay. I think Gurpreet, this might be an issue on your side then, if everyone else is getting clear voice. Yeah, you are right. Okay. So you got the basic idea like
I
how
think
a
it's just better
program
to
gets
restart your machine.
sorry.
I think for him, just better to restart the machine, and then it will work perfectly.
Okay, okay, fine. Gurpreet, I believe in recording the voice would be clear. So the part you have missed, just rewind back and look what we were talking about. All right. And in case you think like uh, there is some confusion or doubt, you are always welcome. You can ask. Okay. All right. Um, we have discussed Java. What is Java? We know where we have seen like four kind of applications we can build using Java: standalone application, enterprise application, and mobile apps. So in mobile apps, like you guys have seen Android, most of the work has been done in last couple of years was in Java, but from last 2 3 years, Kotlin is getting more popular, and people are shifting from Java to Kotlin as well. But yes, some of the projects are still in Java for mobile apps. And why? Okay, the question is why we should learn Java. So basically, what I'll say is from Java 9.11 it was open source, but for 15 I believe for commercial use we need to buy a license. So and one more thing, like why we should learn. So for Java 15, I would not say like it is open source. That's why we are using it. But yes, if we talk about earlier version, yeah, it was open source and provides different kind of functionalities, provides robust mechanism to write or build an application. We can do network programming. We can do digital signature development. We can do encryption decryption using Java. So there are a number of things that is basically provided by Java, and that's why it was quite popular. And if you go back and see like I haven't checked from past few months, let me just check what are the top 10 programming language. So for now I believe it would be a JavaScript on top. um, 2017 we were looking on the latest. So till 2017 Java was on top. According to firstbytes.com, C is on top, then Java. Yeah, different sites has different information basically. Okay, you can Google it on your own because different sites have different data, different stats. So I'll now got into deep. Okay, now we also covered history and Java features. Internal Java program we will discuss for sure in next class. Now we have discussed difference between JDK, JRE and JVM. Okay, now let me start with details of JVM. Okay, so let me just look if I have the diagram for that. I think I don't have. Okay, let me draw that. Okay, so we are just going to talk about JVM. So basically what JVM is, Java Virtual Machine, right? In Java Virtual Machine, there are 5 runtime data areas that is got created on runtime. These are called runtime data areas. Okay, what are these 5 different areas? Okay, let me just type the name. The first one is called method area. We'll discuss everyone in detail. Okay. Then we have something called as method area. Then we have heap. I'm sorry, it's getting weird. Okay, let me just do one thing. Let me open one on online because drawing it taking too much time. Yep. Yeah, you can see this image. Okay, let's discuss this one. So there is a method area, then we have heap, then JVM language stack, and then we have PC register, then we have native method stack. All right, and then we have execution engine, native method interface, and native libraries. And on top of that, we have class loader, right? Okay, so these 5 areas we have here is called runtime data areas because these are called at runtime. Okay, so what is the purpose of a method area? Let me discuss that. So method area is that area basically where all the class code, whatever we are writing inside a class is going to store. So whatever we are writing inside a class will be stored in method area. Okay, then the next thing we have is heap. Heap is basically that area where objects gets created in Java. So you might get asked, what is a heap? So heap is a memory area where objects gets created. So whenever someone asks where objects are gets created, you can say inside a heap. Okay, then we have JVM language stack. Okay, so what exactly a stack is? A stack is basically a data structure, right, based on last in first out technique. Like you can see plates in a kitchen. Let me call it a P1, P2, P3, P4. So we put P1 in the beginning, then P2, then P3, P4, and then P5. But when we want to get one plate, so what we will do is we will pick the P5 first, then P4, then P3, like that. So we can say last in first out means which plate was came at the end will go out in the beginning. All right, so here what is the stack I have just described a bit. We will discuss later on. It's a separate topic, how to create a stack in Java, or there is an inbuilt stack as well, we can use that as well. So basic idea I believe you got. Okay, now what JVM language stack? So JVM language stack is basically to keep track what are the different methods we have, what will be the next method that will be executed. All right, so in a program, we in last program we have just main method, but in coming days we will see we will have different methods, like, and control can be go from main to another method to some another method, right? So keep track all these method execution. We have a concept called JVM language stack. So it will keep track what is the next method that will be executed. You getting my point, guys? In case any of you have any doubt, stop me and ask questions. Okay. Then we have PC register. PC register is basically to keep track what instruction would be executed next. Like we have JVM stack to keep track which method would be executed next, right? PC register which instruction, like in a method there might be 100 line, that is not recommended. Generally we keep it short, up to 10, 15 lines of code in a method are fine, considered fine, best practices. We just not write more than that, but yes we can as a programmer, but that is not really a good practice. If there are something like which is going beyond 10, 15 lines, we should break it into another method. Okay, so PC register is basically to keep track what are the different instruction we have in a method and which will be executed next. To keep track the execution of instruction which we have covered, which will go next, right? Responsible for that. Okay, now we have native method stack. Okay, in some cases there might be like our Java program is talk to or wants to talk with some native methods. So generally what is a native method? A native method can be a function written in a native language like C++. Okay, for example, we have already a program developed in C++. There are some function written over there, and we want to use that function in our Java program. We want to call them. So where that function will be executed will be on native method stack. Getting my point? If we have Java method, then Java method will be executed on JVM language stack. But if we have something called as native function written in C, C++ or other native languages, then that will be executed on native method stack. Any doubt so far? Or should I go to the next step? Execution engine and native method interface and then native method libraries. Okay, I believe all good so far. Repeat please, Harsha. Okay, from which point? From the beginning. Okay, let me start from the beginning. Okay, so method area is, I'll share the notes as well, so don't worry. Don't try to try to remember everything. Okay, I'll save the document, don't worry. So method area is the area where all the code we are writing for a class is going to store. Then the next area is heap, where objects will be stored. Whatever objects we are creating will be stored in heap. Then we have Java language stack, or in some images you might find Java method stack. Okay, so what basically it is for? It is for keep track the methods of Java we have in our program or application, which will go next. All right, then we have PC register concept. PC register is basically to keep track what is the next instruction we will execute or will be executed. Then we have native method stack. Native method stack is the area where native functions get called. All right. Okay. Then we have execution engine. In this, we have two things which is not shown here in image. What are those two things? One is JIT compiler. I have given you brief context about JIT compiler in last session. Okay, then one more thing was there, interpreter. So basically these two are the part of execution engine, which is basically convert our byte code into machine readable code. Okay, so what is JIT? JIT is basically just-in-time compiler, and then we have interpreter, right? So these both works together inside this execution engine. Okay, and where we have concept of both JIT compiler and interpreter. The technique is called adaptive optimizer, where we have JIT compiler and interpreter both. Okay, one more thing to note, do not conflict it with the Java C compiler. This is altogether a different thing. Okay, now what next we have is native method interface, what it does and what is the role of this interface. So a Java program wants to talk with the native language program. They cannot talk directly. There should be some mechanism introduced that acts as an interface or a mediator so that they can talk. So that's why there is a concept introduced here is native method interface. So this interface is basically responsible for making communication between a Java method or Java program or a native language program. So generally in native languages, you might hear a concept of header file who have worked with C or C++. So native library are basically header files in which you have some functions defined and you want to call them functions into your Java program, then this will come into picture. Okay, got all the idea. Now one thing is there that is called class loader. What it does, so when we say this command Java and then class name, so what it does basically, class loader checks, verifies if the byte code is perfect there is no compilation error, uh, or all it passes all the requirements. So what it will do is it loads that class or the application into JVM, right? This whole area. So in this area, what we have is 5 runtime data areas. So when the class will be loaded into JVM, there will be 5 memory areas will be created on runtime. Okay, there is nothing like we have these area defined. So every time we runs a JVM, it creates these 5 runtime areas, all right? And once the program execution stops, the JVM gets removed itself from the memory. Okay, let me try to show you if I can. Thread dot sleep. I'm taking a 10-second delay here, 10,000 millisecond basically. And then we will print by. Okay, this is our program, and we can run it here. Let me just show you. We got hello Java. Now program is waiting. And then after some time we will get by. You can see here, right? So to put some delay between these two execution, we are using thread.sleep. Okay, now let me just try to show you if I can. Okay, I'll run this program using command line. Java hello world. I'm in demo project actually. One second, guys. This is open the task manager as well, so that we can see what is happening. I think this is not required. Let me close it. Okay. So we have a process of Java running here. One Java update scheduler is running. This is basically to check if there is new Java version available or not. Okay, so at that moment we have only 2 Java process running on my system. Okay, let me just sort them. Okay, so basically the rest of the process are from background. The foreground process we have in Java, that is basically running for Eclipse that we are running. Okay, now what I'm doing is I'm running this program, hello world. (19). Still there are 19. But the guys who are on Windows 7, they can clearly see there will be new process will be added, like when our program is running. We are not able to show that here. Okay, now I have one question for you guys. What is the program? Anyone can answer? What is a program? Set of instruction. Okay. Perfect. All right. What is a process? A process is a running program. So I was just trying to demonstrate that, but here in Windows 10 we cannot. But if you guys have Windows 7, then you can see when you run that program, you will find a process here. Okay. Okay, so any doubt in JVM, like how it works, what are the different areas, how to go task manager? Just if you are on Windows, just right click on the taskbar and just say task manager, and you will find this kind of view: process, performance, app history, startup, user details, services. Okay. What we are checking here? We are basically checking if I'm running a Java program, then it will be reflect in your process under task manager. Here, like you can see, here are 17 process. One new process will be added here. It will consume some CPU, it will consume some memory, disk, network, if it is making networking calls. Mamta, are you on Windows 7? Yes. Okay. Were you able to run your first Java program? Okay, fine. Okay, I'm giving you one class file. Just try to run it and see if you can see that process in your task manager. I'm just sharing with all you guys. This is a class file to compile. File sharing option is not there. Okay, just try with this code. Okay, meanwhile, if anyone has any doubt, can ask. Otherwise, we will move to next.